Jumbo. We're looking at balancing nuclear equations. These examples will be the simpler ones. We'll get to more complicated ones next day. You need to find a sheet that says nuclear decay, and it's got a picture of a person wearing a radiation suit. And we're going to do 5 examples today, and then we'll finish off the other 5 next period. Here are the steps, and they won't make a ton of sense quite yet, but we'll just rattle through them. Don't have to copy them down. If you end up needing them, I'll print them out and post them. When you look at an equation, you look at the side where you have all the information. In other words, where the blank isn't. We're going to start by dealing with the bottom numbers on that side, and the total of that bottom numbers will end up equaling the total of the bottom numbers on the other side. And then we finish off by balancing out that bottom number. Once you have a bottom number, that's going to be an atomic number for an element, or it could be the number for an electron, a proton, or a neutron, or a positron. And then we repeat steps 2 and 3 for the top numbers. Again, that may be mumbo jumbo, and I think showing you examples will have it make a lot more sense. And that's what it says on this slide. So we look at question 1. And what we see is, first of all, it says 42K, but it didn't give us a bottom number here. So we have our periodic table handy, and we see potassium lives at spot 19. Now I'm going to start on the left side because I have all the information there, the blanks on the product side, not the reactant side. So there's a 19. So I would need to write in a number. Let's see if we can choose a delightful color. And what we see is this side on the bottom has to equal 19 as well. So once we know that, then we go 19 minus 1, which means plus 1, and we have the number 20. 20 plus minus 1 is 19, which equals the other side. Once I know that's 20, piece of cake, I go to the periodic table, and I see it's calcium. Now I look at this side. Total's 42. There's a 0, so this has to be 42 as well. And that is now balanced. I balanced the bottom numbers first, and then the top. We'll do 4 more of these fun examples. Also notice this is beta decay or beta emission because that is a beta particle, the electron. Number 2, same problem. Plutonium, they didn't tell us what the number is, so we'll fill that in from the periodic table. And we find it way down near the bottom, 94. Well, we look at the bottom numbers, and we start on this side because we know everything. This is 94, so I should do this faster. So this has to total 94. Fried chicken. That is supposed to be a 94. So I go 94 minus 2 is 92. 92 is uranium from the periodic table. On the top I see this is 239. And so I make that 239. Yikes, that's terrible. 9. 239 minus 4 is 235. So I balanced the bottom numbers, identified the unknown element, and now I balanced the top numbers. And you look at 42He, this particle, and you say it's on the right side. So that's alpha decay, or alpha emission, the helium nucleus. Door number 3, same game. We have uranium-235. This time we don't have to fill in an unknown bottom number to start. It's already there. That's 92. So we say, okay, same old game. Boom. This has to be 92. So we go 92 minus 90, and that happens to be a 2. What lives at spot 2? Helium. This side's 235. Jiminy. So this has to total 235. This way you may want to do your work on another sheet. Rough it out first. 235 minus 231 is 4. That is now balanced. And amazing, that's alpha decay or alpha emission, just like the last one. Notice the top number dropped by 4 and the bottom number dropped by 2. Door number 4. Nice tiny numbers. Well, we can't start on the right because there's nothing there. So we start on the left and we go 1. And 1 is duh. So that means we're going to have a 2 on the right side. We know that's helium. We look at this and say, hey, 1 plus 3 is 4. So this side has total 4. There's only one beast there. So that is 4. But this is not alpha decay. In this case, we're putting things together. So it's an example of a fusion reaction. We'll do one more example. And you can see the blank is on the right. So that means we got to start on the left, and we have all the bottom numbers of the particles indicated. And so we cleverly go 3 plus 0 is 3. So on this side, this has to total 3. 3 minus 2 is 1. Once we know it's 1, we can put in H. Hydrogen lives at spot 1. We do the same thing for the top. 6 plus 1 is 7. So over here, the top numbers have to total 7. So we need 4 plus something equals 7, or 7 minus 4 equals 3. So we actually made tritium in this case. That's a good place to stop. We'll finish off the 5 other examples in tomorrow's lesson. And we'll also do some where we're going from the wacky world of words to having to write out the whole thing. And that means when you're doing these questions, you want to have your periodic table handy and also your table of particles and your types of nuclear reactions. That will give you some idea of how to attack these fun things. That's it for now.